All right, everybody. I think we're going to get started right on time because we got a lot of information to talk through, and you guys have all been here on time, so you get the benefit of seeing it all. Everybody else has to go look at the recording. So, hey, my name is Paul DiMarzio. I'm here as part of the Enterprise Ethereum Alliance, and I'm the Director of Community there, and I'm joined by two really bright folks, Marley Gray of Microsoft and Jonathan Levi of HACERA. And they act as the chair and co-chair of another organization called the Token Taxonomy Initiative. I will explain the relationship and differences between the EA and the TTI in just a few minutes, but be aware this is not an Ethereum talk. This is a platform-neutral talk about tokens that we're going to go through. So I'm just going to take 5 minutes to set the stage as to why we're here today, and then let the smart guys give you the details about the actual technology and the standards behind it. But one thing I find time and time again in trying to talk about tokens to folks is there's a misconception of what a token is, and it's usually grounded in the fact that, or the unfortunate fact that the first two tokens defined, Bitcoin and Ether, come from a cryptocurrency environment. One is a token that has an intrinsic value all in of itself, and that's it. The other is somewhat of a community-based token, but still, anytime you want to talk about tokens, people immediately call into their mind that this is a cryptocurrency space. That is one part of it. There's a lot more to it. So what I like to generally do is take a look at tokens today. I mean, we all know what a token is today without any thought of digitization. It's simply something that represents the value of something else, right? So dollar bills represent the ability to pay $1 worth of tax to the U.S. government. Diplomas represent the fact that you've gone through a rigorous course of education and you got that piece of paper. You got tickets. You got UPC codes, all kinds of stuff that represents something of value. And some of these have been digitized in a certain sense today, but not in the context we're going to talk about. I mean, if you've been flying, you probably used your iPhone or your Android phone, to have your ticket on it. But that's not the same discussion. That's really just taking something that has a tangible, a physical value and turning it into something electronic. Very different story. When we're talking about digital tokens, we're talking about things that they reside on a shared distributed ledger. So this is the concept of a multi-party agreement that is documented and shared on some sort of a medium. It could be a blockchain. In many cases, it is a blockchain. In other cases, it could be something else. Even simple databases can act as the basis for a distributed ledger. They're cryptographically secured, so the owner is well known. The ability to spend is a one-time deal, or to transfer is a one-time deal. And the representation of what you can do with the token is based both on how the token is defined, how it's been built, as well as the basis of the rules of the underlying ledger. All right, so this is something that I hope most of us do understand about tokens and the digitization of tokens. So then the question is, what's the problem, other than the fact that most people think this is totally crypto space? The real issue is that there's no standard language for defining tokens. Now, coming from the Ethereum world, whenever I raise this point, the first question I get asked, what ERC standard are you talking to here? Not the right question. All right, ERC standards, chain code standards and other platforms all have to do with how the token relates to the underlying structure. That's not the concern. What I'm talking about here is when you're actually defining what are the behaviors of the token, what are the characteristics, what are the sorts of control messages that can be driven through some sort of a smart contract to actually make that token function or to reveal its value. These are the kinds of things that we want a standard language for that we do not have today. And that means that of the tens of thousands of tokens that are already out there in the field and that are being developed every day, people are doing them as one-offs. They're creating them new. Yeah, my token's going to be fungible. Let me write that out, what that means. It's going to be transferable. It's going to have all these other characteristics. Everybody does it one step at a time. This makes it extremely difficult for developers to get together and collaborate on some sort of an interoperability strategy for these tokens. It also makes it very difficult to talk to the business people about what these tokens are supposed to do. So we're looking for a standard language for defining these things. We also want a standard way of controlling them, and we want to get that blockchain influence out of the conversation. We want to talk about the tokens for what they are, they're representations of something of value, and let's focus on that. So the thought here was to create something called a token taxonomy. If you think about it, all tokens are really compositions of pretty much the same things. As I mentioned, there are behaviors, there are characteristics, there are control messages. Many of these are already known and understood. New ones are coming up every day, but we do know that they are composite entities. All tokens will have a common set of these things. The way they differentiate themselves is which ones they use, how they put them together, and how they bring them to market. You know, my director sitting in the front here, Ron, he's a musician, and he likes to talk, well, he thinks he's a musician. And he likes to talk about the fact that, you know, there are 12 notes in the musical language, but there are an infinite number of compositions based on those notes, and more being developed every day. And if you write up some music using these notes, then a lyricist can write lyrics to that song. You know, a musician can then pick that up and understand how to play that song. Everybody understands the language of the notes and can use them to build something new and unique, right? And that's what we're looking for. So we call this thing a token taxonomy, right? And this is what we're focusing on in this presentation today. How do we develop a platform-neutral token taxonomy to take on this task? And this is where the Token Taxonomy Initiative came into play. It is an organization that was initially supported by the EEA, and that's why I'm here today, because we initially saw the value in this, and because so many tokens are written in Ethereum, we decided to go ahead and get this kicked off. However, I'll give you a piece of information that nobody else knows except for you guys in the room. The TTI has grown to be big enough and substantial enough that within a week to 2 weeks, we'll say 1 week's time, it's going to be set free. All right, it's going to become the Token Taxonomy Consortium. It's going to be taken out of the auspices of the EEA. It's going to have its own governing body and be a standalone entity. So, you know, this stuff is real. There's a lot of work behind it. It's very real. And the whole purpose of the initiative was to do exactly what I said, to create a platform-neutral taxonomy, to have the right people together to make this happen, and to put together this TTF framework. So before I turn it over to Marley, I'm just going to want to leave you with one metaphor that I think helps to understand, you know, where the TTF runs and where it stops. You all know about baking cakes. Now, maybe you've never baked a cake before yourself, but you know how it's done, right? First step is to understand what the ingredients are. Milk, flour, eggs, whatever it is, you pull those together. Think of these as artifacts that represent the behaviors and characteristics of the token. There's a catalog of these things, and you're going to pick the ones that you need for the specific recipe, which is the second part, that you're actually going to put together. The TTF defines the artifacts that represent the ingredients and the recipes. So we're basically creating token specifications, and we're stopping there, all right? What you come out of this is a full-blown specification automatically generated by the tool that developers can then go and code into the cake and the slice of the cake. Went too far, all right? So think of the cake as basically being the class of the token, and the slice as being the instantaneous. All right, I'm done talking. Instantiation of the class. So with that, think about that metaphor, and now Marley's going to come up, and he's going to take you through the details of the TTF, how it operates, and how it works. So there we go.
Thanks, Paul. You guys hear me? Is this on? All right. So I'm Marley, if you haven't met me before. So we'll talk about the TTF. So Ron alluded to the Token Taxonomy Framework as under the cover. It's just a GitHub repo that has a set of these artifacts. And the artifacts are just essentially descriptions of ingredients. So just like we said, you can have ingredients in the cake analogy, eggs, milk, sugar, and things like that. Before you start making a cake, you want to know what your ingredients are. You don't want to start mixing things together if you're missing 2 or 3 key ingredients you have to run to the store. So what you need to do, can you guys hear me? How about now? Still? Yeah, this mic isn't. There we go. All right. So the artifacts are just essentially a set of files that you pull together. Now, the thing with ingredients is you get a list of them, but you also need to know how many eggs, how much milk, how much flour, how long do you stir, or whatever you do with cake batter, what temperature to put the oven on. All of those things are not put into detail until you get all the ingredients together. So this is just the classic way we create composition frameworks. So you have two parts in the token taxonomy. You have artifacts, and I'll talk about them in a minute. And then you have what we call templates. And templates are essentially recipes. And they have two parts. They have an ingredients list, and they have a definition where you fill in how many eggs, how much flour, that kind of stuff. So let's talk about how you select these things. All right. The first thing that you do is you pick what we call a token base, and tokens have this classification characteristics, and I'll talk through these very quickly. And these aren't final, but these are the ones that we find to be most common. The first is you have a token type, whether it's fungible or non-fungible. So hopefully most of you are familiar with these two concepts, where fungible tokens are a lot like money, where you are interchangeable within the same class. They have the same value. Non-fungible tokens do not have the same value with other tokens in the same class. So we have that. There's the base type, or we call the token type. Then we have token units. Token unit is fractional, whole, or singleton, and there's some. These can be a little bit confusing, but fractional tokens are dividable or divisible, meaning I can make change. If I have a whole number, one token, and I need to have 0.35 tokens, that token is said to be divisible. Whereas whole tokens are indivisible, meaning they can only be whole numbers. So certain tokens make no sense to have subdivided portions of that token. And a singleton is sort of a unique definition where there's one and only one in the class. So you would create, it's wholly unique, and I'll give you an example. A property title. Property titles in the United States, if you're from the US, they all look the same. If you ever look at a property title, it's a piece of paper, and it's a specific format per state, per the county that it's filed in. They all look the same, but they all have different values. So you can put two property titles side by side on the table, and they look identical, other than the fine print. The value comes from the actual address that the property title is anchored to, right? And depending on where that property is and the size of that property, the value for that property title is wildly going to differ between each other. Those look identical. Those two property titles are in the same class, but they have different, they're non-fungible in the same class. A singleton is essentially, you can only have one property title if it were a singleton property title. There can only be one in the class, no more. And that's just a nuanced thing that sometimes shows up in implementation. Value types, intrinsic, meaning that the token has value on its own, or reference. So intrinsic are like cryptocurrencies, and then a reference is like a stable coin. So it actually references value somewhere else. The token itself doesn't represent the actual value. Representation type, we have common and unique. Let's see, common tokens typically can share properties, like the property title. A property title will have the same county and state and country, but they would share that, but they would have all different values underneath. So you can have common representations. Unique ones, that means they can have their own unique values, and they're not shared between any other tokens. Then we have this new one. This is actually new for the framework, called supply, and this is where you indicate whether it's fixed supply, if you have of your token class, capped variable, gated, or infinite. We'll probably add variations on these, but those are the different types of supply. And then the template, we have this notion of creating a single token or a hybrid token. And a hybrid token lets you model out more complex business use cases, which we'll talk about in a minute. Once you've picked your classification, you sort of go through those, and these definitions that you're seeing of the classification are mostly for educational purposes. When you look at the token taxonomy, there's a lot of plain language definitions for business people to read about what each of those classifications would be, so that when you come up with a standard, you can look at the classification of a token and get an understanding of exactly what, or for the most part, how this token will behave. These are just some syntaxes that you look at in the token taxonomy. You have common and unique fungible, where you see these formulas of these symbols. The token taxonomy has a standard formula. It's not a complex. When you look at these formulas, it look like there's some wicked complex math. It's really not. It's just a composite or a composition. But it does do validation against the syntax, so it's helpful in the back end when you're trying to build templates. But anyway, let's talk about hybrids real quick. Once you define tokens, whether they're fungible or non-fungible, you can combine them in interesting ways. So let's talk about, let's assume that, pick a band, let's say, the Grateful Dead. Remember, they used to come to town, they would stay for a whole week. And you would buy a ticket for Tuesday, or tonight. Is today Tuesday? Yeah, tonight. Or tomorrow night. You would buy a ticket for the Grateful Dead concert for tomorrow night. But they're here tonight. You can't show up for the Grateful Dead concert with that ticket for tonight, or for tomorrow night, and get it in for tonight's show. But the thing that ticket does share is its non-fungible parent, meaning it's for a specific date, a specific time, but it shares the other values. So it has a non-fungible parent with fungible children, because there could be millions of, well, not millions, thousands of general admission tickets for a Grateful Dead concert. You might think there are millions of people there, depending on what you take at the Grateful Dead concert. So that lets us mirror out things like mortgage-backed securities, theater tickets, and things like that, where you can create hybrid definitions. Once you have a base token type, you then differentiate tokens based on their behaviors. So behavior is either a restriction or a capability. So transferable, most capabilities will often have an opposite, so non-transferable and transferable, divisible or indivisible. Some are just be mintable. So mintable is the same as, not necessarily the same as issuable, but they'll have these different behaviors, and they're usually described, and they'll have other aliases. So all artifacts can have aliases that have the same meaning in a different industry. So mintable might not make sense for people that aren't in the cryptocurrency space, but if you give it a different name, like issuable, even though there's a separate issuable behavior, it lets people get their head around what a behavior does. Behaviors can have properties. This gets a little bit into the sort of programming definition, but essentially, behavioral property is a property value that is calculated to be set or calculated to be read. So it's controlled by a behavior, and it's not just a static value sitting out there. Here's a list of common behaviors. This is not complete. There's a whole bunch of these. They have symbols as well. They're just lowercase letters. So you can see the palette of these. And these are added. We have a lot of these. And these typically, you can think of behaviors as not necessarily the token implementing a specific set of logic or implementing the behavior, but having the hooks to be cryptographically linked with a contract that actually performs that feature or that capability. So like insurable is a behavior on a token. Doesn't mean that the token is an insurance contract, but it rather means that the asset itself can be cryptographically linked to the insurance contract somewhere else on a completely different ledger or wherever it is, but it will have that cryptographic link hooked into the insurable behavior. Behavior groups are just shortcuts. Sometimes you'll see behaviors that go together all the time. Building composition frameworks is a delicate balance of knowing when to stop decomposing things to where you could decompose things so much they're not quite usable. But if you decompose things like this is the one we have in the framework is called supply control. Supply control combines mint, burn, and roll support, where there's a role defined called the mentors group or the mentors role. That means you must be a member of the mentors role or group to be able to call the mint function. Those three things go together, and we can it's a way for you to create a template for things that go together all the time and pre-configure them as a mini recipe, if you will. Properties are, we already talked a little bit about behavioral properties. Those are properties that require you to go through the behavior to set them or to get their value. A non-behavioral property would be like a skew, sort of a setting or a property that you would set the value for once, and then you just want to query it. And you want to make sure that all tokens of this class have this property, and you can just inspect that token, and you'll get the value for that you're expecting to get. Now you can still have, in the programming language, we call them getters and setters, and you can still have controls around the setting of those property values. The interesting thing here is we can have properties nested within properties. So you can define complex structures as what we call a property set. It's pretty easy to do, pretty straightforward. Both behaviors and properties have something called invocations. And invocations are just a fancy way of saying, how do I call this thing? How do I invoke the behavior? Or how do I get the value of that property? And those are defined as, those invocations then have control messages, which are just high-level descriptions of a transfer request message and a transfer response message. A mint request and a mint response. So it's call response. And it's not in programming language, but they're just called control messages. In the framework, you define them in, pretty easily just by defining an invocation, give it a name, put in the parameters that you have to pass in. So a transfer requires an amount and who you're transferring it to. Not overly complex. Now, once you have all those are basically the different types of artifacts. All those artifacts are classified or categorized in buckets. And then you go out and you want to compose a token, and you can pick from all of those parts that are in the framework and build your ingredient list first. And then once you build your ingredient list, you've got your formula up top. And then you can build your definition. And that once you have a definition, you now have a token template, and that could generate a specification from the definition itself. The specification is just a PDF or an OpenXML document that the tool generates for you that you can hand to somebody, and it has some thud factor, and it looks like you put a ton of work into it when really you didn't spend that much time on it. But underneath you have classes. That's where you get to the implementation. So somebody goes and implements that. And then the instance is the token that you would have in your wallet, or the balance would be instances of that. Let's see, the formulas. This is what a template looks like. The ingredient list is displayed as a formula. So you have this is a fungible token that is divisible or indivisible, sorry. The tilde is the opposite. So D is divisible or not. G is called delegable, so I can delegate. Supply control has mint, burn, and roll support. And then it has a property called skew. So that essentially is my formula. And that doesn't tell me how many who's a member of the roles, of the mentors group or anything like that. That goes in the definition. That's in the formula. The definition is when you plug the actual details in to say, hey, this thing is divisible by X number of decimal places, or the role support will have these other roles that are be members of them, and then people can be members of those other roles and things like that. But that is the definition that creates the details. That's sort of like your recipe step by step. From that, we create the specification, which again is just a document that tool generates for you, and you can build those. And the interesting thing about those things, I'm going to show what this looks like. But the definitions themselves are versioned, so you can publish those, and it'll be a specific version that developers can go program against. Each artifact has a map or a set of maps that can have references and links to source code implementations, finished implementations, or reference materials like regulatory guidance as well. So here's how this thing works. People say, okay, this is a bunch of noise. How does this thing actually work? So if we start out, we say, well, these things basically put together a toolbox for you, and you can go out and grab the different artifacts from the different pieces to build your token template. What does it look like in practice? This is just a sample visualization. In the GitHub repo, there's the library out there has, you can, if you're comfortable editing JSON, you can create artifacts yourself. You can modify them yourself right within the GitHub interface or use something like Visual Studio Code. But there's also a service in there that you can run the service and you can use it. It uses a gRPC, has a gRPC interface, and it will serve up an object model for you. And then you can build applications against the object model. And it will provide CRUD sort of interfaces back and forth. So there's really no user interface specified. We do have a very rough web interface. We're going to show you a couple of different ones. Get ready to show you a mock-up. Again, this is a mock-up. This is what it would look like. This doesn't exist yet. We do have prototypes. But this is what an example would be. You would start the token designer, and here you'll see the visualization of these palettes. So on the upper left-hand corner, those are my token bases, where I'll say drag and drop a essential token base over. When I drag and drop it over, it'll put it on the design surface. If it has any dependencies, it will automatically pull those over. So in this one, we're creating a singleton, so it grabs a singleton behavior automatically and puts it in there. And then I can just drag and drop components onto my design surface. Now this tool, down in the lower left-hand corner, you'll see it's building a formula as you drag and drop. And if you try to drag something on, like, if you try to drag divisible and then indivisible, it won't let you do that. It will be invalid. So it will do real-time validation as you're designing your formula and your token definition. So I can build out my token designer. You can use this to create a whole new template, and then you can save it. In this case, we're creating a bill of lading. You can also use it to set the definition. So I can, as I'm going in, I can hover over it, and I can set the number of decimal places. Or I can set constraints on a property and put, and here we have a regular expression validator to say, hey, only characters of this type are allowed in this field. You can also use it for education. Somebody could pull up a template and pull it into this and hover over individual aspects and get information of each of the different components, whether it's on the right-hand side of the screen or as a pop-up. So the artifact implementation is, again, in GitHub. These are all just JSON artifacts that are serialized from protocol buffers. The protocol buffers can be served up via gRPC, or you can edit the JSON directly. If you're a developer and you want to clone the repo, you can go hack at it and you can create your own artifact. If you make a mistake, you start the service up, it'll tell you exactly what's wrong with your artifact, like if you don't have a unique ID or something like that. It's pretty straightforward. But that's not good enough. We need more tools, and we're building those. We're going to show some more here in a bit. I could show you the web one. Oh, I can't on this laptop. But there are some tools that let you, the end result, the end goal is to get this in front of as many business customers and business analyst types, not programmers. So they can have a design surface where they can understand and build tokens from a business perspective without having to understand the technical underpinnings. So we get a solid set of requirements from that we provide to developers. So the last bit is, where does the TTF stop and where do you start? Or if you're implementing code, the TTF is just going to define the artifacts, the templates, the specification, and then it maps to any of your resources. So if you go out and you get an existing specification and you write some bang up solidity or a chain code implementation in Go for this artifact or this complete template, and you want to advertise that, you can put that right in the token taxonomy framework and issue a pull request, and that will be discoverable by any of the other people looking. So if somebody models out a token that you just so happen to have written an implementation for, they'll be able to discover you through this framework. So with that, I'll hand it over to Jonathan, and he's going to give us a demo. And it's going to look just like this one I showed earlier, right?
That's good looking. Yeah. Can I use this, maybe? Yeah, sorry about that. First time I speak in a conference, yeah. Hello, everybody. Yeah, I'm Jonathan Levi. I'm the CEO of HACERA. I'm the vice chair of the Token Taxonomy Initiative that is going to be probably the Token Taxonomy Consortium. And some of you heard that a few months ago I became the vice chair of this whole thing, worried about, am I not busy enough? And I am busy, and so there are some people here that I still need to send invoices to, and we don't have time. But I really think that this is a very important topic, which is why we're taking an active part in this. So let's talk about portability and interoperability. And I think that this is one of the biggest issues that we have when we're talking about adoption, platform risk, how much you invest in something, things are moving. Can systems talk to each other? Can people talk to each other? Can companies, can enterprises talk to each other in a way that doesn't require so much coordination, because enterprises are not really built to collaborate by nature. So we started, well, actually many people here know me from the Fabric days, right? And in the Fabric days, when I was working on 0.5 and 0.6 with Gary, and we were actually, I personally was worried that it's not going to be like an IBM thing, right? And I wanted to work on multi-cloud, and the first demo I gave at CoinDesk Consensus 2016 was how to connect Fabric from Google Cloud to the IBM Cloud, and we actually spent a lot of time trying to make sure that things are interoperable. And we had the same problem with Sotus later on, that we wanted to have it like in a platform agnostic way. But look, 3 years later, we have a lot of cloud support and a lot of blockchain as a services. We're partners with Azure, Oracle, IBM, and even Amazon. Even though they're working on 1.2 of Fabric right now, it's possible to run a blockchain as a service in a multi-cloud fashion. The problem that we had at the time was we don't have a unified interface. So we said, okay, look, let's just build an overlay network that allows a multi-cloud deployment. This was based on Hyperledger Fabric. We released this thing. We started listing out projects and giving them names, and we integrated with the Ethereum naming services, the ENS, and then we created another naming services for Fabric. And we actually worked a lot to kind of solve the identity and privacy, and we had some governance on top, and yeah, that was great. So we thought we were done, but we are not done, because we needed to also share some logic. So some of you here know that we partnered with Digital Asset a long time ago, like a year ago, and we showed the first DAML implementation of ISDA, the ISDA model, the CDM model. It was in London, Synchronized Europe last year, and we showed how we can easily connect a DAML smart contract or a DAML app to Fabric without changing Fabric. So we have something called unbounded scale, which is a smart contract abstraction language. And we thought, okay, that's going to be very easy. Now we can easily run any smart contract that you like, even a Java chain code, even like I have some stuff in Solidity. There are some projects that actually connect. And now I am kind of multi-cloud, multi-blockchain, and I'm kind of almost logic agnostic. So are we there? I don't think so. The main problem that we have is actually all this stuff didn't work without a way to tokenize in a correct way. So we didn't speak the same language. So Ethereum did very well by defining ERC20, okay? But it was not enough, and then they started working on ERC721, and then there's 14, there are so many, like the privacy ones and the security ones, et cetera, et cetera. Fabric is talking about Fabric token for quite some time. There are a lot of issues in terms of like keeping it generic enough to kind of be a financial services-based kind of framework that also has supply chain with a lot of identity, hash commit reveal schemes, so Fabric is getting extended all the time, and it's not so easy to kind of find the right token model that will work with everything. And we were thinking, okay, why don't we build a tool that actually is able to work with a standardized form of defining a token that will work across the board. So let me try to show a live example of what it looks like. By the way, questions? Usually I speak too quickly. That's fine. It's the end of the day. Everybody's happy to hear me speak quickly. So we built a tool that allows us to actually create a token template. Is the text okay? Oh, why is it not showing? Interesting. So let me. I have to quit the presentation mode, maybe. Yeah. Telling you, first time I'm presenting. Let me kill it. Sorry, 1 second. I don't know what you're going to see now. Oh, we're back. So here is a framework that allows me to just go to my tokens. Is the text okay? I don't know if it's big enough or not. And I can just create a template. And it's something very similar to what Marley showed you with the mockup of a designer. And I can basically choose a base type of a token. It's going to be a whole, fungible, fractional, and I can try to go with the combinations that I allowed, okay, for what we support. And it's actually supposed to be very simple to basically come in and let's try to find, I don't know, let's do a function. No, let's do a whole non-fungible token. Should we do that? Or I can actually do a unique, okay, let's do something like cash, right? So I can just come in, and once I've chosen the base type, I can start like adding some behaviors, right? So I can say, I want to be able to delegate it, and I want to be able, and then everything here is like relatively well explained in a form that I can just have it, well, I don't know if I can do delegable that is not transferable, et cetera, and then I can have this combination. And I promise people on LinkedIn that I am going to call this thing fab token, right? So let's call it fab token, but we're going to call it like fabulous token. And basically, I have the same thing as the formula that you saw before, but if you look at the actual taxonomy definitions, it's not that difficult for us to have a unified kind of one-to-one relationship between basically the representation of what are the properties and behaviors that I would like to have, and to actually generate a token that later on I can just go and, let me just see that I'm generating the right one. I can just go and upload the implementation, and this actually may be a bit complicated, but I'll talk about it. So while this is deploying, I'm deploying it now to Unbounded, I'm deploying it on a Fabric network. How many people here worked with DAML before? 1, 2, 4, 3, yeah. That's it? Okay, so I want to spend like, I don't know, maybe like half a minute to talk about digital asset kind of, and the language that they open sourced, which is one of my favorite languages for working with digital assets in the financial sector world. Very functional, very easy to use. Instead of us worrying about like, Solidity is actually very flexible in terms of like working with message.sender. Fabric is very easy because I have attribute value sets. DAML is very simple when you want, in our cases, we just looked at a few settlement cases where it's very, very simple for us to understand what's going on, have the logic, and then I can have versioning of a contract, of a token, I can split it. It's a lot easier to do it in a functional way. And we partnered with Digital Asset a long time ago, and this allows us to actually have an abstraction layer that sits on top of, let me just see if I can find it here. Fabulous token, do I have it here? I supposed to be able to run a Fabric. If it was deployed, it should be here. This is the previous demo, by the way. I hope to have a fab token here. Fabulous token, here you go. So I actually now deploy a DApp that actually uses DAML for settlement, working in a multi-cloud form that actually conforms to the token taxonomy framework that we define. And I'll just show like an example of what it looks like. I just deployed Fabric like a minute ago. I have blocks, transactions, normal Fabric world. This is actually running this time, no offense guys, on Oracle blockchain platform. Last time I showed DAML, it was on Azure. We work with IBM, we work with other kind of blockchain platforms, but it doesn't matter. Fabric today is generic enough for me to be able to work in a multi-cloud fashion just by using the Fabric API. And we spend a lot of time trying to make this thing very clear. Is the text clear to everybody? Is it too small? Is it okay? Okay, so I can just go Bob, Alice, and I have a wallet here with cash, and I have a wallet here with tokens. And I can just create something called like delivery versus payment, and it's just a commitment that I'm going to buy 100 tokens for $50, or I'll be able to move. This is an example of a bond trading app that we actually presented to a few companies recently, and we're productionizing it. But I can say I would like to have 100 USDs, and my token, let's say 50 tokens, and my token symbol is going to be fab, and the issuer here, oh, I see. See, now you know that it's a real thing. And then basically I submit a proposal that is now written to a chain. This is a bit complicated in terms of finance, but basically I have like 4 steps. I basically create a proposal, submit it, then the recipient can either accept or reject the proposal. If they agree to agree or agree to disagree, that's fine. But let's say they did agree. So I basically accept the offer or the DVP. And then basically I allocate here something. And then I settle on the other side. Okay? So this whole exchange actually worked on Fabric, but without loss of generality. We could have done it on other things. Just that we have a product that runs on Fabric, the Diamond Fabric kind of interface. And it's very easy for us to just take a standard token. I didn't change a single line in the Fabric code base to make it work. We actually work with Fabric to make sure that we can basically have a full end-to-end kind of work with Diamond on Fabric. But the idea is, once I have this tokenization framework, this is just one example of how we did it on Fabric. We basically can generate that framework with the interfaces that we support, with the properties that we want to have in the token taxonomy framework kind of form, and then we can at least talk the same language. Because if you look at, what's the time I have? Okay, a few minutes. So my main concern today is that, yeah, we're making a lot of progress in blockchain, right? And we started with a single thing that worked on 4 nodes, and then we started adding more nodes, and then we had the ability to add a node to a network. We have Ethereum coming in now with a private offering, right? There's the Bezo and the permission offering. And if you ask kind of my personal view, not just as a vice chair, but just as Jonathan Levy, I don't believe that we are going to end up with one single blockchain. I didn't believe that we are going to have it when we had only Bitcoin before Ethereum. I didn't believe that Ethereum is going to be the next or the last thing. And I don't think that there's going to be only one Fabric network or maybe one version of Fabric in production, right? And that's already the case. So I'm not telling you anything kind of new, but back in the day it was new, you know? And when I started working on permission kind of chains, everybody like, hey, what happened to you? You used to be a cool guy working on public chains, et cetera, et cetera. Why are you going corporate again? Because I really believe that we need to have real users with real applications, with real assets on these chains. And if we are not going to have real assets and we are not going to tokenize them, think about it for a second. What are we not double spending? Okay, so we all have to work a little bit harder, at least at the beginning. And the last few years were actually, I think, promising. Hard, but it was expected, but promising. Because many companies now don't believe anymore that they should just have a lot of things in the data silo. People are talking about some public validation. And people are trying to tokenize stuff in a way that they can move across networks. So take a step back. Imagine that I would buy a handset today, and I'm going to connect to, I don't know, Verizon or AT&T. And every time I want to send Bryce a message, I need to know the maker of his handset, like what network is he on, and I don't know if he's available right now. That's not the system that we have today, kind of in the sense of 24/7, I don't want to work 9 to 5, and I have full auditability and transparency. So all I need to do is to just have a component that basically builds stuff in a way that is not just platform agnostic, as was mentioned here, but also implementation agnostic. I would like to have accelerators in terms of like hardware, software, libraries, tool sets, networks, platforms that will be able to work in a similar way. And they just have the same behavior so that we basically can align expectations, right? I know what I'm getting. I know under what conditions I'm approving stuff. I know what I'm not accepting, et cetera, et cetera. So my message to everybody here is that actually we didn't want to just sit in a room or in a lab and to create a framework and just throw it on, over the fence to everybody. It's an ongoing process, and it's actually growing, and we're getting a lot of good feedback. We're looking for problems. We're looking for different tokens, different behaviors, more property sets, what we did wrong, what needs changing, what is really keeping you up at night, and how we can help. Last things I would say, I don't think this is going to be the last version. This is version 1.0. I think we need to also, now that we are in Hyperledger Global Forum, I would like most or all project maintainers and people that are running kind of the different frameworks to start thinking about how we can work together, because I think that we are too fragmented right now. And I'm not saying it just because I like Fabric so much, because I spend so much on Fabric. I just don't think that we have enough resources to build so many fragmented systems, because we're just confusing the users and the client and the ecosystems. Questions? Thank you. Oh, yes.
That status, and when is that going to come back, if you know? And how will this play with that?
Sorry, say again.
How will this token taxonomy framework
Oh, actually, so I was just joking about the fabulous token because we had fab token and then we removed it, so I didn't want to call it fabric token, even though it's running on fabric. Actually, there are a few people here, the fabric maintainers that should talk about it. You got Gary's one and there are a few other people in addition to me, so I don't want to talk on the behalf of the fabric project on my own right now. We should talk about it. There are plans to get fabric. I don't know if it's like in 2.1 or 2.2. So there is a big move now on how to design a token. We just did something, and we did DAML in this example, not just because we wanted to promote DAML right now, but because we wanted to have an abstraction layer that doesn't actually sit on Fabric. So I just wanted to use Fabric for state, but not to have something that is super embedded in Fabric, just to show, like the big message here is I can work in a standardized way without baking in and hard coding everything to the underlying network. That's why I did it. But we should talk about Fab token with pleasure. Yeah. Okay.
So just one last point. We are really over time. I'd like to break. If you want more information, go to tokentaxonomy.org. You'll be able to find some documentation, some specs. You'll be able to find out how to join the TTI, soon to be TTC. And we have a little more information at the EEA table up at the Developer Center. So thanks, Marley. Thanks, Jonathan, for doing this work. And thank you all.
Bye, everybody. Cheers. Nice.